In this example, I would like to find real number values for a and b such that the equation we have here is true. So let's go ahead and remind ourselves quickly of the equality property for complex numbers. And that simply states that if we have two complex numbers in standard form, a plus bi and c plus di, they're going to be equal to each other if and only if their real parts, a and c, are equal to each other, and their imaginary parts, bi and di, are equivalent to each other also. But of course, for the imaginary parts, we don't need to consider the I because both of them already have the I. So I can just say b equals d, and that's just from our little property here. Okay, so let's look specifically at this example. So I have the real part, this negative 11 over here on the left side, and then I have this 3a minus 2 over here on the right side. That's the real part. So I just need to go ahead and set those equal to each other. And then I can go ahead and solve for a. So let's go ahead and add 2 to both sides of the equation. So these 2's cancel. So I have negative 9 equals 3a. And when I go ahead and divide both sides by 3, I can isolate that a, and a equals negative 3. Or I can use my symmetric property and just say a equals negative 3 that way. Okay, so there's my value of a. So let's go ahead and tackle b. So our imaginary parts then is 6b with the I, and then negative I radical 6, so I need the negative and I need the radical 6. But the I don't need to consider when I write this equation because both sides already have the I. So 6b, and that's positive, equals negative radical 6. Okay, well if I'm trying to get the b by itself, I can just divide both sides by 6. So it looks like my value for b will be negative radical 6 over 6. Okay, so there are my real number values for a and b that will make this equation true.